All right, ladies and gentlemen, welcome back, and this is going to be the last of our triangle centers here. We've looked at the incenter, we've looked at the circumcenter here, the intersections of the angle bisectors and the perpendicular bisectors respectively. Now we want to see, can we do this with other things? Okay, so let's give this a go. We're going to construct altitudes now. Now, if you remember what altitudes do, so altitudes, again, go ahead and create perpendicular lines here. So we're going to have to go ahead and do the same thing here. So I'm going to create perpendicular lines to each of the vertices of the triangle here. So please, if you haven't done so already, try it yourself. So unfortunately, there's no real efficient way of doing this here. You're just going to have to do your best and do the construction 3 times. Okay. So I see an intersection point here, we can do that. I see an intersection point here, we can do that. Okay. So that's the thing from A. I'll do the thing from B now. Nope, that's too small. Let's try that again. Do this from B now. That's too large. There we go. Here's B. Right, and I can see the 2 intersection points here. So here's one here. Ladies and gentlemen, I really suggest that if this is something you're not sure about, go watch the video on constructing perpendiculars again. This is something that we definitely have done in the past, and I expect that you know, oh, that's not good. And I expect that you know how to do. Okay, I accept that. It runs through B, close enough. We're very close to B here. Go ahead and construct that. So now we can see that we have our intersection points. So now I can go ahead and construct my altitudes here. So hopefully this will work out. So here's my altitude like this. So I've got 1. I've got 2. And finally 3. And finally 3. Well, would you look at that? Lo and behold, they all run to the same point again. They run through a different point here, but they all intersect at a point like so here. So yet again, we have another concurrency. So this point here, this is the intersection of the altitudes here. So this is here, happens to be known. We refer to this as what is known as the orthocenter. Okay, so this here, ortho meaning, at perpendicular or right angles to, like an orthodontist or orthogonal. We refer to this in the mathematical literature, we call this point here H. So the orthocenter here, H, this here happens to be the intersection of the altitudes of a triangle, right? So we refer to this as the intersection of the altitudes of a triangle here. Now, you'll note here that there are certain situations with the orthocenter. So for instance here, consider the following, right? And I'm not going to construct this here. You can construct this on your own, but I'd like you to consider what's going on here. Imagine we have an obtuse triangle like this here, right? Now, it shouldn't be too hard to show what's going on here, right? We can drop a perpendicular like this. This is a perpendicular like so here. We can drop a perpendicular. However, notice how here it's actually outside the triangle, right? Because this is an obtuse angle here. So we can drop a perpendicular like so, and it's going to be outside the triangle. Similarly, over here, we can kind of do the same thing and drop a perpendicular like so, and we do the same thing here like that. So notice how in the blue triangle, if the blue triangle is obtuse, this point here is on the outside, right? So this is where H is. So notice how one important thing to note here is that for the obtuse triangle, H lies outside of the triangle, okay? That's an important thing to note here. Now, it's kind of hard to prove here, but I think you can kind of see this, and if you have access to GeoGebra or some other computer geometry software, you can experiment with this yourself. Similarly, as we saw over here, this was an acute triangle. We can measure the angles. It worked out pretty well for the acute triangle. So H lies inside the triangle. Okay? But wait a minute. Okay, so we can try one more time. We can try the we can try a right triangle here. So with a right triangle, well, let's see. Well, here's a right triangle. Well, hold on. Clearly, we have an altitude like this here, right? So that's an altitude here. But note, wait a minute. C to AB, we create a perpendicular line. That's already there. That's this segment here, right? That's this segment. Similarly, if we want A to BC, we want it to be perpendicular. That's that segment as well. So that's our orthocenter. So the nice part about the right triangle here, that H is at the vertex of the right angle. Okay? So note that in this situation here, we can actually show that this is the case. And you can actually do a very similar analysis for the circumcenter and show that it changes positions based on the kind of triangle that you use here. Whether you use an obtuse, acute, or a right triangle here, all of them work out.